Hello everyone, welcome back to another video of me studying. Today, for the first time, I will be studying using the Pomodoro technique. So, today I'll be studying for 3 hours from 5:40 until 8:40 with the Pomodoro of 50-10 for 3 sessions. For information today, I'll be studying physics and math, as you can see here. So now, without further ado, for your information, I'm using this app for my Pomodoro to show you the timer here. It will appear here. So now, without further ado, let's get started, shall we? Well, not exactly 5 to 40. We will start early. Okay, on. Okay, let's get started. Wait, never mind. I need to go and re-access the app. While waiting, I'm just going to take everything out. D10, these sessions, and we start. I'm not sure if you can see the timer, but it's okay, I guess. So this is moving. Okay. Okay, first period finished. Let me start the break. Oh, because 2a here, so ut is that plus 2 this one, 2 so 1 so over 280 square. Okay. 2 plus there's as here. Yeah, because s here is from here. Maybe this one. And there is something here. Let's see what this is looking for. afterwards I'm going to start back. Experience. Afterwards, I'm going to try a question. Question 2. Question 2. See what to do or not. Okay. Get this away from the moment. You just get this. Minutes left. This question is asking acceleration. So this was okay. And then we learn the linear motion graphs. So this is at rest. It should be here. With uniform velocity. Here like this. At rest like this. Macam tu. for the last period, I'm going to do every exercises for chapter 2. We're gonna take, since I already did this, no, both faces. Okay, 30 seconds left. Oh, it's 6:36 already. Started let's get started. So, for question 2, so I do is stops after 5 seconds. So, question 2, moving until it stops. Question 2, A equals to B, T. So A is equal to 0 minus 30 meter per second over 5 seconds. 6. This is definitely solution. Question 3. We want to find the displacement. Top B, we already have the final velocity of 5 meter per second, initial velocity of 1 meter per second, as well as the time taken of 5 seconds. The formula that we're using as displacement is displacement, so S equals to 1 over 2 U plus V T. Then we just be the mass of 1 over 2 U is should be initial, so 1 plus 5, and then wait, no, 0.5 minutes, so this is 0.5 minutes, so this is 30 seconds times 30 seconds. So just calculate. So should be the answer now. But if we want the answer, do you have an answer in this video? So for question 2, performance evaluation video. This was productive practice 2.1. We scan it later. Now I'm gonna take up my laptop and get some questions related to the my laptop's of course off. That here now. So now I want to get questions related to this world. So question 2. Yes. Please get my pen. Yes, the car decelerates. Okay. This is the formula that I'm like asking. Then you just mark. This is the correct answer. Now for question 3, they're asking this one. So this was the correct formula. So and this one correct, and this should be the correct answer. So we'll got this question ready. Now I want to do the next part. Okay, let's go to ChatGPT and I will search for the related exercises. Okay. Now we got a couple questions from ChatGPT. A motorcyclist travels 80 meters east, then 50 meters west, and 120 meters east. Okay. One question. Let's continue for question 4. So, west is Tamba, east is Tolak. So, where's 80 plus 50? A. For B, we want to talk about the displacement from the starting point. So, total distance traveled. And this is question B. Question A, something like this. So just plus everything. 80 plus 50 plus 20, 150 meter. Now, for average speed, how to find average speed? The speed, okay, so question 5, average speed is equivalent to distance over time. So the distance is 1.2 kilometer over 8 minutes. And then they say they want to find count it in meter per second. So 1.2 times 1000 meter per 8 times 60 seconds. So 1200 meter over 180 seconds. We get 1.5 meter per second. Question 6. They want to talk about average velocity. So the velocity is equivalent to displacement over time taken. So displacement is 300 meter north, so it's minus 100 meter because this one is, and then they say no average velocity, no. So we want to find average velocity. So to find average velocity, I think it's like 300 meter over 20 plus 15 meter per second, and then we have meter south in 10 seconds. So is it 15 plus so it's like 0.167. I'm not sure. Just think about it. No. So A equals to 17 minus 5 over 4 equals to 2 meter over 4 second. 2 meter second. Next opposite. Use the formula here. V equals to plus AT. So a ball is thrown upon an initial velocity of 12 meters per second. 12 meters per second. U So u is initial velocity. Initial velocity is 12 meters per second. A is acceleration. Velocity. And then two is acceleration. Acceleration is here, 9.8. And then the time taken is 1.5 seconds. You get negative 2.7 meter per second plus here displacement. So we have s equals to ut plus 1 over 2 at squared. So 3 meters per second for 6 seconds. Rest. So we know u is so now we want to find the acceleration which is no displacement. So s equals to u is the initial, so 0, and then at second, time taken 6 seconds, so over 2, acceleration 3, and the time taken square, so 6 square. So s equals to 0 plus 1 over 2, 336. S is 0 plus 1 over 2, 108. So s is equal to 54 meter. So should be 8 now. Now we have 32 minutes left. We go to a bit for 2.2. Okay, now about 2.2 is about linear motion graph. So let's start with the displacement now. So, interpretational graph is important to understand the type of linear motion of an object. So first, we have displacement minus time graph. So s minus time. So now, you look at the object at rest. So it's always uniform like this because it will not go up or not go down. So it's not like that. It's always like this. This means it's not doing anything at all. Object moving with uniform velocity. So if the velocity increase, that means from the origin it will increase at the positive gradient. Moving with acceleration, so acceleration it will not increase uniformly. So one time it will increase like this, it will increase like this, or increase like this. Oh dear, this thing is okay. Now for velocity minus time graph, so velocity is v, so uniform velocity. So uniform velocity means it will just maintain, it will not go up or not go down. Moving with uniform acceleration. Uniform acceleration means it will increase from the origin like this, because it says uniform. If it says uniform, it will always be like this. So uniform is always like the positive gradient. Oh. Object moving with uniformly decreasing velocity. You see the word decreasing? Decreasing means it will go from the higher part to the low to the origin. So it's like this, just like the negative gradient. Moving with, okay, now acceleration a minus t. Moving with zero acceleration. Zero acceleration, it will not appear at the graph. It will just stay at the origin there. Uniform acceleration, so it will always like this, because acceleration will go up, it will be like this or like this. So not is it, if it's uniform, it's like this. This one means it's not uniform or not. Now increasing acceleration, increasing, so from the origin it will go up like the positive gradient. Now velocity for displacement time graph, gradient of the graph is velocity. So velocity here, so this is the gradient. So velocity time graph, so gradient and is the acceleration. So gradient is the acceleration here. So this one is the gradient. Area under the graph is called displacement. Under the graph is called displacement. Next, we go to this part here. Analysis of displacement time graph to determine distance, displacement, and velocity. Figure 2.1a shows the initial point and final point of the motorcycle ridden to the right, which is the positive direction, and then to the left, which is the negative direction. The displacement time graph in figure 2.1 now shows the linear motion of the motorcycle. So first it goes to the right, so right is the positive, then it moves to the left, which is the negative. So in AB, we want to find the velocity first, so the gradient of the graph will be 100 minus 0 and 5 minus 0. Where is AB? So AB here. This is at the example of the graph. So find the displacement. Displacement is here, so we'll start from the highest to the lowest. So highest to lowest, and then 5 minus 0, highest to the lowest. So it's 20 meters per second. Stops for 3 seconds, it will be 0. So stops for 3 seconds, 0. This is 0. B to C, the displacement, this means the object is at rest. So the object rests. So now it's ridden back to initial point A in 4 seconds. So we want to find why is it decreasing. So it's because of here the moving with no uniformly decreasing velocity. So this is from 0 to 100 minus 12 minus 8. Yes, 12 minus the highest minus lowest. So and then we have this highest minus lowest. So now this is the cause why we have negative 25 meters per second. So DE means it's stationary at initial point for 2 seconds, so it's 0. So initially it's 0, so that means this one is actually 0 acceleration. And for EF here, ridden to the left for distance 15 meters 6 seconds. So now we want to, it's going down again, so it's decreasing again. So lowest minus highest. Final minus the initial over 20 minus 14, because this is the final and this is the starting point, which is the initial. That's why we have this. So the distance travel, yes, 100 plus 100 plus 50. So initial point 100 plus 100 plus 50 become 100 250. So displacement is 100 minus 100 is 0, plus minus 50, that means is negative 50 meter, 50 meter to the left. So now the distance traveled is 250 meter, a total of 20 seconds, because you can see here this is the final time. So the average speed is, you of course divide this and this now to get the average speed. The displacement is negative 50 meter, total time 20 seconds. Average velocity, you just do the same thing lah. Now, analysis of velocity time graph to determine distance, displacement, velocity, and acceleration. We have exercises related to this. Yeah, we do. We have this one. So now here. So the linear motion of the bicycle. So first, this guy, he go, I don't know how many meters it is, and then he go back. So now, this is the graph we are taking a look. So time interval for 0 to 50 seconds. The first is the gradient of the graph, which is 0 meter per second. So with the uniform velocity of 10 meter per second. So 10 meter per second uniform. So according to the velocity time graph, this one is here is a uniform velocity. Now, time interval of 50 to 70 seconds. So gradient 50 minus 10. Because you can see here, final minus initial. So 50 minus 10 over 70 minus 50. Final minus initial. So you get 5 over 20, which is 1 over 4. So 0.25. So that's why it's increasing, because of the positive gradient. Now, time interval of 70 to 100 seconds. The gradient of the graph is this, because 70 to 100. So low final minus initial, 0 minus 100 over 100 minus 70. 100 minus 70. So 100 divided with the, wait, no, 15. Because final minus low initial. So negative 15 minus 30 is negative 2, 0.5 meter per second. So the velocity of the bike gradually decreases. The bicycle accelerates at 0.5 meter per second in the opposite direction to the motion of the bicycle. The time interval 100 to 220 seconds. This one is called stop. The velocity is, this one is at rest. So if you refer to the displacement, at the displacement there, it says that the object is at rest if at acceleration. 0 acceleration means it's at the origin there. This is equator to origin here. This one means 0 acceleration. So now we want to find here 120 to 150 seconds. So gradient of the graph is negative 9 minus 0. So negative 9 is 0 over negative 150 minus 120. So y-axis minus negative 9 over 130 is, we just use calculator. No. Negative 9 is 0. 150 minus 130. So negative 9 minus 30 is negative 3 over 10. So it's negative 0.3. So negative 0.3, the second is like going down. Now, to find the distance, L1 plus L2 plus L3 plus L4. So L1 is definitely, my goodness, L1 is, so now before this we want to find the area. So area L1 is 500 meter. Why? 50 times 10, I think. L2 is 250 meter. Why so? Because if you do triangle here, 70, 20 times 10 is 20. So, and then we have the triangle plus 1 over 2 times, I think it's here times here. 20 times 10. 50, so it's 70. 250, okay. 250 meter, how is it now? If you do this, 20 times 10 is 200, oh, 200, so 200, so 20 times 550, so 250 meter, like that lah. L3 is 225 because same thing, 1 over 2 times 30 times 15, so it's 225. So L4 135. L4 is located here, so we have to do this. 1 over 2 times 30 times -9. Okay, so wait, no, 1 over 2 times 30 times 9. We get 135. So now we have the area here. So we have to find the area first. So 500 plus 250 plus 225 plus 135, we get 1110. So this is the distance. Displacement to the right, meaning 500 plus 250 plus 225, 1975. Right first, and then we go to the left. Left, we get the area for L4 because this one is the set triangle. Now, to calculate the displacement, you have to calculate the right plus including the left. So 500 plus 250 plus 225 plus -135, we get F40 meter to the right. So we're at activity 2.3, which means I have to do, I don't know, now. Now, let's look at example 1 here. Figure 2.24 shows the displacement time graph of an object in linear motion. So you see here, from 0 to 6, it go up. Why? It go up, and then form a rectangle. Okay. So we need to find every change. So we have 1 change, 2 change, and 3 change. All is right side, so it should be good enough. So 0 to 6 seconds. So we have to find y-axis first. 6 minus 0 because 6 is the initial, the final, and 0 is the initial. Do the same thing as x-axis. 1. Now we go here. Because this is stationary like this, rest, that means this is automatically 0. Now, displacement time graph, so later on. So now, 12 to 20 seconds. So 12 to 20. So this is the more complicated part. So y is 10 minus 6 because 6 is located here. So 10 minus 6 over 20 minus 12 because 12 is here. So 20 minus 12. So 4 over 8, which means it's 0.5 meter per second. So to implement it in the velocity time graph, here we have to identify 1 meter per second like this. Also cannot understand why it's just like this also. Oh, because uniform acceleration and because it's not increasing acceleration yet, so it should be like this. Oh my goodness. Now, for example, 2. Dear me. Example 2. My goodness, it's making my mind so dizzy. This question now. Figure 2.26 shows the velocity time graph that is plotted based on the linear motion of the car driven by Ajay Kasim. He drives his car in a speed of 30 meters per second. He applies the brakes when he sees an obstruction on the road. Interpret the velocity time graph of the motion of the car and sketch the displacement time graph and the acceleration time graph. First, we want to identify the amount of sections we have in this graph. So 1 and 2. So 1 and 2. So it's like this. So 0 to 6 seconds. So this one is the velocity. So we have to remember find the area. So to find the area, we have to times the bottom and the side first. So 6 times 30 is 180 meters. So to find acceleration, you see here, the acceleration is just constant only. The uniform acceleration. So it's maybe like this lah. No, it means this one have uniform velocity. So now displacement area B, so it's a triangle, so we have to 1 over 2 times the side and 10 minus 6, so we have 60. So acceleration, so we have to calculate from here. 0 minus 30 because 0 is the final, 10 minus 6 because 10 is the final. So this one, displacement time graph from 0 to 6 seconds, it may not increase to 180 meter. Is the gradient. From 6 to 10, it's 60 meter. Not just any 60 meter, it should be increasing. Since this one, it says it's accelerating. For acceleration time graph, this one maybe don't have any acceleration, and this one is the uniform acceleration but in negative. Oh my goodness. Now this question, let me see what question I can do. think I can do question 2. Wait, no, question 2 I do 3 and 4. Let's see how to do the questions. So this question, yeah, I need graph paper for this. Second is stand by here. So for question 3a, so the average velocity is v, right? V over S over T, displacement over time taken. House to sundry shop, so 400 meter. V equals to S over T. V is equal to 400 over time taken. So yes, 3 minutes. 20 seconds of 180 seconds. So 400 over 180 is 2.22. This is for one. Number 2, sundry shop to the playground. So V over S over T. So V is equivalent to 300 meter over. After 1 minute, in 2 minutes. So 2 minutes 120 seconds. So 300 over 120, we get 2.5 meter per second. So number 3, playground to the house. So now we don't know the length of the shortcut here, so we have to do Pythagoras theorem. So 400 meter plus 300 meter, 450 meter plus 350 meter. Wait, no, 400 meter, sorry. So 400 plus 300, we get 26. Wait, 400 and 300, so it's 10.7. So this question is making my balls high. Okay. So now this question, 400 plus 300. Do they give such kind of no 400 meter, so 1 plus 2 is the wait, oh, I think I forgot square. 500 meters, so 500 meter, so velocity S over T 2 we get 4.17. Average speed. So 250 meter. So first we have to plus everything. So 400 plus 300 plus 500 over 27. So 3 1 2 2. 3 plus 1 plus 2 plus 2 times 60. This one makes 1200. 8 times 16, 480 equals to 0.5 meter, 0.7 meter per second. Now, this is for B. Now, for question 4, we have to draw the graph. I don't think we have done anything. We don't want to do that now. Yes. So, I think that's it for physics. Now, let me check. So far, in 2 sessions, we learned 2 subtopics only. 2.1 is about linear motion. Linear motion is about the distance, displacement, speed, velocity, and acceleration. There are 5 main things in here. There are differences between displacement and distance. There's uniform velocity and non-uniform velocity. And there's formulas to find speed, velocity, as well as acceleration. To find distance is seperti bahasa lah. Acceleration you have to be specific. Wait, no. Displacement have to be specific. Because to the right it may be plus, to the left it may be minus. And then we learned about the sticker tape, as well as the solving problems for linear motion equations. For linear motion graphs, there are 3 types: displacement, velocity, and acceleration. And we learn how to solve using the graph. So that's it lah. for this physics. Now take another break, and then for the last session we'll be doing math. Okay. So I have this from my old primary school. Okay, chapter 1. Wait, no, do not do chapter 1, chapter 2. I think we do every question for comprehensive practice. Question 1 to 13. left. 4 minutes left. Oh, the chapter 3 then. Chapter 3 is all about words, as well as a bit of calculation. So, 35. One minute 54. One minute left. Okay, 26. Okay, 15 seconds. You know what? Let's just start now. Okay, for question 1. Complete the following number sequences in ascending order. So first we have 2, 3, 4, set. Base 5, we have what and what and what. So now, how to find the ascending order? So now, So first 2 3 4 to set 5. So now imagine if I convert it to base 10. So I can just 101. So 10111. So 110. 7. So if I divide with 7, 7 divided with 2, we get 3. 1. 1. 8. For question C, $37. So 37 21 0 21 10 22 31. Not 31. Okay, so it should be it for question 1. Question 2 will ask about the place value of digit 2 and 3240. So 3240. So the place value digit 2. So this is in base 4. 42 43. Digit value 40 times 0, 41 times 4, 42 times 2, 43 times 3. So now we want the number value. So this is 0. This one is 16. This 4 times 4 16, 16 32. 4 times 3 64, 64. This is 192. So we want to find this one. So 32. Now for question 3, they are asking this to base n. So 1110011 square to base 8. So how to convert to base 8? So it's separately 3 digit. So 1 2 3. So 110 001 001 010 011 1104, I think. One one zero is 6. 6. So it's 6. So we have 6 1 this 8 7 617. Next, convert 367 to base 2. So how? So first we have 3 and we have 6 and we have 7. So now what is the hasil? 3 2 plus 1. So 3. The value of 3 is 011. The value of 6 is 110. The value of 7 111. So it's 11110 Now question 4. Convert 2 at 7 9 to base 2 to base 8 7 base 5 base 8. First we have to convert to base 8. So base 10. So 2 at 7 plus value digit value number value. So this is in base 9 9 0 9 1 9 2. This makes 0 1 177 9 9 it's 72 81 81 2 is 162. Is it 182? 81 2. Yeah, 162. So this one you add become 这个234 so it's become 237 to 10 power. So 237 10 we divide with 2. First divide with 2. 1 1 2 3 8 9 2 18 6 add 2 16 1 5 9 2 8 9 sorry 1 4 what is 59 divided with 2? 59 divided with 2 should be 29. 59 with 2 is 29. 2 14. This one makes 7. This one makes 3. This one makes 1. And this one makes 0. So the answer is 1110101 base 2. For B, we do the same thing but base 5. So 237 base 5, 4 20 20 37 7 35 2 5 9 5 45 45 2 1 5 4 5 0 1. So the answer is 1422 base 5. And then we have C base 7 237. Base 7, so 237 base 7, so we divide with 7, 7, 3, 2, 21, 27, 3, 2, 21, 6, 7, 4, 7, 28, 28, 5, 7, 0, 4, 4, 5, 6, 7. Question D, base 8. 3 at 24, so 2 at 16, 77, 9 at 72 is 5. 3 at 24, 4 at 32. Wait, no, it's not 4, it's 5. So it's 3, 5, 5 base 8. Now we go to question 5. We need to add. So question 5. Add 110 base 2 plus 1110 base 2. For me, I have another method which is to minus. So to minus, we add base 2. This 10 plus 0 adds 1, 1, 1. 1 plus 0 makes 1. 1 plus 1 makes me 2. 1, 2, 3. 3, 1, 2. So now we minus 2, 2, 2, 0, 1, 2. 0, 1. So this is answer. B. 1407 plus 3027 minus, so we have 7 at the end. This makes 2, this makes 4, and this makes 4. And C, 2759 minus 2189. So this one is not enough, so we'll go for 6. So we want 9 plus 5, become 14. 14 minus 8 is 6. 6 minus 1 is 5. So 56, 9. For question 6, we have 56 minutes. Question 6. Determine whether true or false. So 6. A. So 1, 2, 3. We have to do this. We convert everything to base 10. So 1, 2, 3. This one makes 3, 8, 16, 24, 27 to the power 10. And then 23 at 3, 6, 8 to 16, 19 to the power to 10. So this one is true. For B, (72, 972), 9091. So this is 2. This makes 63. And this one is 3415. This one is true. Yes, correct. So the answer is just 269. Question 8. We have 30 minutes left. Can you minus? Or now we can just cover the base and not. So 2, 3, 1. 2, 3, 1, 4. 1, 12, 32, 5, 0, 2. 0, 2, 4. Question 9. Given 1, 1, 2, 2. Forty-four to the power of the base of 10. Question 10. Oh dear, the final max. This makes 65, and then 66, 66. 21. So I took a 5-minute crab break. Okay, now let's go back to business. Okay, 1489. 1, 2, 1, 2, 5, 1, 2, 6. 1, 7, 6. 2, 4, 7. 2, 5. 2, 6, 1, 2, 7, 1, 2, 8. 1, 0, 0, 3. Okay, so question 11, January 31 days. So, base 5, so base 5, so 2, 0, 2, 0, 5, 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 0, 25, 25, 50, 1, 2, 5, 1, 5, 0, 1, 2, 5, 0, 1, 2, 5 plus 50 plus 0 plus 5, next one 4, 3, 0 to the 10th power. So it's basically 1,430 people. So now in each day, oh dear, I want to go toilet again. I have the urge to go toilet. So answer 1325. This is 0. 305. It opens every day. Oh, 0132. Okay, so let me get this straight. 20302. So 50515253854. One 1302. What is the average number of visitors to Zoo Negara each day in January? January have 31 days. That means it's 42. Ah, like that. Okay, good enough. Now, question 12. Question 12. Azizan buys a 20 minutes left. Azizan buys my goodness, this question. 100 small balls, 1/5 balls are green, remainder is blue. So green equals to 20 balls. Next yellow, 25 balls. 10 balls. So 80, 55, 45 balls. Give it base 8. No. Question 13. This one 25%. So first, base 7, base 8, base 7. Okay, I'm done with this part. Now time to sum up. First, I want to go to the again. Everything already. history. Nothing happened. Oh, 4 minutes left. So my shitting got to work. So nice. Okay. No, no, this one. One 0 1 1 1 0 0 0 1. Oh my goodness. True false. This 269. 39 105 65 11011. This one is 1325 55 8 42 7. Okay, good. So overall, I've slightly messed up the topic, just careless mistakes here and there. So I guess that's it. Just have to wait for the timer to end. Last minute. Hopefully it didn't show camera. So anyways, thank you for watching this video. Subscribe and more will be posted in the future. See you.